Hi, my name is Cooper Hazel, and I'm presenting my final project in MIS 4460 Business Analytics on problems with Excel regression. My problem was doing academic level quality regression analysis in Excel. It was a big shortcoming for me because originally I was trying to do my regression analysis in Excel, and then I ran into so many problems that I thought I would create a presentation that highlights the problems and why someone should avoid doing any high level or academic level quality regression analysis in Excel if they can. My original problem was to model a research question that I will later show, which I was going to use this diagram for. It's kind of like doing my data collection, my model building, and my analysis all in Excel. I was going to use Excel as my primary tool, some Excel add-ins and some array functions as well. My model was built around marijuana consumption's effects on taxable food consumption. We decided to control for various demographic figures like poverty rate, unemployment rate, race, and age. I attempted a difference in differences approach, which is kind of a standard in evaluating policy effectiveness. The R-squared did not change much when I dropped the difference in differences type model, and I measured that by doing the data analysis tool pack regression. However, the DAT can only handle 16 independent variables, and I had 20 or more. The data was cleaned by me. It was obtained by me and Professor Hodge, who, when I say we, I talk about us too. Although he did not help me with the regression in Excel, he did help me supply the data. This is a research project I've been working on since May of 2020. The data was obtained by various government sources such as the St. Louis Fred, the Census Bureau, the Washington State Liquor and Cannabis Control Board, and the Washington State Department of Revenue. I think data cleaning in Excel in general is a pretty great option. I did all my data cleaning in this project in Excel. I think the filter and sort features and pivot tables, I think they're great for kind of like elementary data analysis, and in my experience is easier than editing a text file. And I should note that some of the data was adjusted based on inflation and CPI, Consumer Price Index. This data wasn't like population or age or anything like that. It was everything that kind of rotates and is based on money. So I would adjust. We indexed everything to 2016 quarter 4, giving it a value of 1, and then we kind of calculated, back calculated inflation and the CPI. So 2012 quarter 1, which is our original data set, had the highest value. Due to limitations with the DAT, specifically the variable limitations, I opted to use the linest function. Linest output is very confusing. It doesn't come with labels. So I used Professor Iskin's labels, although finding the answer online could take about 10 minutes. I found a document explaining the linest function from the university, and they had labels in the document. The statistical significance of the variables are not given, despite this being a standard in other statistical packages. Also, a pretty significant note, the linest function inverts your variables. So as we'll see later in my screenshots, the variables do not relate or are posted in order of my columns. They're reversed. This is a screenshot of a Stata output. This isn't my data set. This is someone else. There's a link to the YouTube video in the notes of this slide. As you can see, they have R-squared. They have the adjusted R-squared. Adjusted R-squared was not included in the linest output. They do have the T statistic and the p-value for each variable, which was not included in the linest output. And they also have confidence intervals, which is also not included in the linest output. This is a screenshot of the eViews output, which is from my data project I used in my econometrics class last year. This is a little bit more advanced. I shouldn't say advanced, but more in-depth in comparison to the Stata project output that is seen in the previous slide. P-value, T-statistic, I would also like to highlight here because that's, again, not in the linest output. And this is an R output, which again, T-value, probability, also shows significance and various things related to the residuals. This is the linest output, and as you can see, there's no labels in the above, so I created a table with the labels below, and it has the coefficient on top and standard errors on bottom. The pound sign n/a was confusing to me at first and very alarming, but then I realized it's just the way that the array function is formatted, so it wasn't a big deal. Now we'll take a look at my Excel document. So this is the data analysis that I did. We'll come back to this. I'm going to walk you through some of the other analysis that I had to do. This is a county-to-county crosswalk that includes every county and its closest MSA. And this is based on the food price index, which I will get to later. So basically we had to assign a county to a high population MSA or the MSA that's closest to it if there wasn't a choice. And I'm pretty sure we deferred to highest population if a county was equidistant. There are some counties and places in Seattle that are across large bodies of water, not oceans or lakes, or I think they're like lakes or pretty wide rivers. So typically we just went to the biggest city in terms of population. This is the CPI adjustment that I did. As you can see here, I averaged it based on the quarter. And then as I went down, everything is kind of flowing off of this 2016 quarter 4 value. And then I ended up stacking the values on top of here from 2012 quarter 1 all the way down to 2016 quarter 4 for ease of pasting inside my data set. This is the fruit and vegetable index. There's a similar index that I don't have included in the file or in the folder for this submission because I think it's a little unnecessary. But it shows basically all these non-taxable food items that we have that weights food price index. So if taxable food revenue and non-taxable food revenue increase, we wanted to make sure it wasn't just because the prices of food were increasing. And then this is the CPI adjustment kind of preliminary document. So I would end up putting the adjustment factor next to the columns and then multiplying it by the adjustment factor to get where I need to be. So this is my data for analysis document. A quick explanation of the variables. We have all of our demographic variables from columns J, I think, all the way to column S. Then we have our difference in difference variables, which every treatment group gets a 1 no matter what period, and every control group gets a 0. Post-treatment basically is a 0 before 2014 quarter 3 and a 1 afterwards. And then we interact the variables. So a control group, for example, is always going to yield a 0 in the interaction because even though they're post-treatment, they have a 0 during the treatment. We have all food tax, which is taxable food revenue, basically the signal for unhealthy food. Non-taxable food revenue, restaurant tax, restaurant units. So if restaurants increase, that might explain an increase in restaurant revenue. And then various measures related to marijuana taxation. At the bottom here, we have our output of the LinS function. And what's really confusing here is the coefficients are pasted in reverse order, which is a big problem and not good for reading. Here we have the summary output of our data analysis tool pack, which I eliminated the difference in difference variables. And as you can see here, for example, the intercept is 10395591.36. And if you go all the way over here to the right, it's the same value. This is very confusing because in an ideal world, in my opinion, that should have pasted in the leftmost column just for ease of use, not to invert, because that means that as you get like this is going to correspond to, well, that doesn't even make any sense because taxable food index is like the values are close to 1.3. So the readability of the LinS function is very problematic in my opinion. Here I just did a regression of the treatment, and again, there's no all they give us is the standard error and the slope coefficients. They don't even give us the probability or the p-value significance or the t-statistic. So in an academic context, trying to figure out which variables are most significant or have the most weight on your y value, it's very problematic to read. Yes, I could kind of calculate these things on my own, but again, that's very time consuming. Here's a summary statistics table that I calculated for Dr. Hodge. Just has per capita values and, or no, these are not per capita values. These are just values in the treatment and control groups with standard deviations for each of the variables.